Welcome to today's Explainer. We're diving into the absolute mechanical magic that happens beneath your feet literally every single time you drive. You know, we all love making a car go fast, but today we're focusing on something way more critical: how to actually make it stop.
Just think about it for a second. Think about that split-second chain reaction that we just completely take for granted. You spot an obstacle, your foot hits the pedal, and boom, a multi-ton metal machine comes to a safe, perfectly controlled halt. But how? Like, what is actually happening in that tiny, tiny fraction of a second?
Well, to unpack this whole process, we're going to cover 5 quick things today. We'll start with why your brakes matter, then trace the step-by-step journey, look at disc versus drum stopping power, uncover the actual magic of ABS, and finally, go over some common problems and maintenance.
All right, let's kick things off with part 1, why your brakes matter and why they really are the ultimate safety feature.
Look, understanding this system isn't just about, geeking out over mechanics or engineering. It's really about empowering you to stay safe out on the road. Because without a properly functioning braking system, every other safety feature you have, the airbags, the seat belts, the reinforced steel frame, all of that is basically just the backup plan. Your brakes are absolutely your first and your best line of defense.
So, how does it actually work? Let's get right into part 2, the step-by-step journey from the pedal to the pavement.
It all kicks off the exact millisecond you press down on that brake pedal. But here's the thing, your foot alone, nowhere near strong enough to stop a speeding car. And that is where the brake booster steps in. Think of the brake booster as a massive strength amplifier for your foot. It uses a vacuum to literally multiply your physical force. Once amplified, that force pushes directly into the master cylinder. The master cylinder's job is super cool. It takes that mechanical push and translates it into hydraulic pressure by pushing out specialized brake fluid.
Next, that highly pressurized brake fluid acts like a high-speed messenger. It races down this whole network of hoses and pipes, your brake lines, until it reaches the wheels. Once there, it commands the calipers to squeeze the brake pads. And this right here is where the magic happens. Massive, and I mean massive friction is applied to the rotors or drums. That friction transforms the kinetic energy of your moving car straight into heat, bringing you to a smooth, safe stop.
Moving right along to part 3, stopping power. Specifically, disc versus drum brakes, and how that friction physically stops the car.
Now, before we compare the two main systems, we really got to talk about those calipers. Honestly, you can just picture calipers as a pair of incredibly strong hands that grab onto the moving parts of your wheel. The second that hydraulic fluid reaches them, they clamp down hard. But what exactly are they grabbing? Well, that depends entirely on the type of brakes your car is rocking.
So, there are 2 main methods out there today. First up, disc brakes. With these, the calipers squeeze brake pads against a heavy, spinning disc, usually called a rotor, from the outside. It's actually a lot like how traditional bicycle brakes pinch a tire rim. On the flip side, we have drum brakes. Instead of squeezing from the outside in, drum brakes use these things called shoes that push outward against the inside wall of a hollow, spinning drum. They both create friction, just in completely opposite directions.
Okay, part 4, the true magic of ABS, or the anti-lock braking system. Because, let's be real, what happens when you have to stop in a sudden, terrifying emergency? We have all been there, right? Someone slams their brakes, or a deer darts into the road out of nowhere.
When you panic and absolutely stand on the brake pedal, the natural mechanical response is for the brakes to clamp shut and lock the tires completely. The huge problem there? Locked tires mean you start skidding, and if you're skidding, you can't steer at all. Enter ABS. Computer sensors detect when a tire is just about to lock up, and they rapidly pulse the brakes. I'm talking pumping them up to dozens of times per second. The result is unbelievable. Your wheels keep turning just enough to let you maintain steering control so you can actually dodge the obstacle while still slowing down. Total game changer.
Which brings us to our final section, part 5, common problems in maintenance, or how to keep your brakes safe.
Let's run through some common symptoms and what they're trying to tell you. If you hear that awful squeaking or grinding sound, it's almost certainly worn brake pads begging to be replaced. Now, if your brake pedal feels sort of spongy and just sinks way too close to the floor, you probably have air trapped in your brake lines messing with the hydraulic pressure. A warning light or generally poor stopping power, that often means low brake fluid, which could be a leak. And if your steering wheel's vibrating violently when you brake, that usually points to warped rotors. Basically, the surface isn't perfectly flat anymore, so the pads can't grip it smoothly.
To avoid those terrifying scenarios, you just got to stick to the basics. Make a habit of checking your brake fluid reservoir under the hood to ensure the level is good. Have a pro inspect your brake pads for wear whenever you get an oil change. And always, always listen to your car. It will usually tell you when it's unhappy with a weird noise. But most importantly, address any of these issues immediately. Seriously, brakes are absolutely not something you can just put off until next month's paycheck.
So to wrap this all up in one nice little bow, your physical press on the paddle is amplified by the booster, converted into crazy strong hydraulic pressure by the master cylinder, fired rapidly through the brake lines via the fluid, and arrives right at the calipers. The calipers then force those pads against the rotors or drums, generating the massive friction required to bring you to a perfectly safe controlled stop. It is just a brilliant, brilliant symphony of engineering.
Now that you know exactly how this incredible chain reaction works and just how vital every single piece of it is to the safety of you and your passengers, I want to leave you with one final crucial question. When was the very last time you actually had your brake fluid and pads checked? Stay curious, stay observant, and above all, stay safe out there on the road.